Okay, today we're going to do 4-6 rational numbers. Okay, so on your paper, I need you to draw something to this effect, okay? So you need to have a little circle right here where it says natural. So you have a little circle. So natural are basically whole numbers without zero. So all positive numbers, 1, 2, 3, 4, 5, all the way up. And then draw a circle outside of that. Whole numbers are natural numbers and zero. So zero and then your positive numbers, 1, 2, 3, 4, 5, 6, etc. Integers, so draw another one. Yes, I'm going to look at these and do integers. Integers are your whole numbers and their opposites. Remember, we learned that in chapter 1. So it's going to be -1, -2, -3, -50,000, along with zero and along with 1, 2, 3, 4, 5, 6, etc. Okay, what we're going to deal with today are rational numbers. And what rational numbers are your fractions, anything that can be written as a fraction. So fraction and decimals that either terminate, which means end, or if they repeat. Okay, so make sure and draw this. I'm not worried about the real right now. You can put that if you want. We're not going to talk about it right now. We'll talk about it in a different section. Okay, so, and then somewhere on your page you want to put rational numbers. Okay, so rational numbers can be written, so these are fractions and decimals. And I'll give you some examples. That end, the book will use terminate, end, or repeat. Repeat a pattern. Okay, so some examples, 1/2, -3/4, 1/3, which can be written as 0.333 repeating, and since it repeats, it can be written as a fraction. And so, yes, that is a rational number. If it repeated 0.253253253, yes, that is rational. Okay, it has to repeat a pattern. Just because it throws in, 0.252678, just because there's two twos there, it has to repeat the pattern over and over and over again. Okay, so, and those can be negative or positive, -0.25. These are all rational numbers. Okay, so your numbers like pi, those would be those are irrational numbers. I'm sorry, I said that wrong. Those would be irrational, but right now we're just dealing with rational. Okay, so make sure and draw that picture the best you can. Okay, so when we deal with rational numbers, okay, your equivalent fractions are very similar. Okay, we have -1/2. The biggest thing to know about here is it doesn't matter where the negative is. It can be right in the middle, or it can go with the 1, or it can go with the 2. It doesn't matter. Or we could multiply by 2 and get -2/4 or -3/6 or 4/8 with the negative on the bottom. It doesn't matter where the negative is as long as there's just one. Okay, it does not matter. So all of these are equivalent. Okay, same with here. The 1/2 could be written as -1 over -2, because remember, negative divided by negative is really a positive. Okay, so we could write it like that, or it could be -2 over -4, or it could be 3 over 6, or it could be -4 over -8. It does not matter. If there's two negatives, that's also a positive. Okay. So same with right here. If we do the -2 over 3, that could equal just 2/3. It's the same thing. Okay, or it could be 2 times 2 is 4, 2 times 3 is 6. Okay, or you can make it -4 over -6. Okay, so the biggest thing is this number 1 is knowing that that negative can go on the top or the bottom or in the middle. Most of the time when I write mine, it's just in the middle. It doesn't matter where it is. Okay, so if we are going to graph this on a number line, so you're going to draw a number line on your paper, on your notes, and I will talk about this in class. When we deal with fractions, my main thing I want you to learn is whether a fraction is bigger than a half or less than a half. And then from there, is it bigger or smaller than 1/4 or bigger and smaller than 3/4? Okay, you can estimate so much better if you know that. Okay, so if we have 0 right here, and we'll do, what do we need to go to? We'll do 1 here, 2 here, -1, -2. So when you have something like this, no, you cannot use a calculator. I want you guys to think about it. Where am I going to put these? Well, 1/2, okay, that one shouldn't be too hard. Not really. It's between 0 and 1, right in the middle, right? So we have 1/2 right there, okay? Well, let's look at -8/10. If we reduce that, we could reduce it and make it divide by 2, so it would be -4/5. Okay, basically you want to see, is this bigger than a half? Okay, well, yes. Okay, because half of 10 is 5. Half would be 5/10. So right now let's just deal with halves. So it's bigger than a half, it's closer to 1, but then we look at this negative right here. It's actually negative. So we're going to look, it's really close to -1, but it's not -1 yet. Okay, and we're not going to make all the little marks right now. You just need to estimate right now. So we could put it right here. -8/10. This shows me that you know it's closer to -1 than 0 as of right now. Okay, I'm sorry, yeah, -1 than 0, right. Okay, and then we have 0.9 because I've just gone blank. Rational numbers can be written as decimals as well. So 0.9 is really close to what number? Well, it's bigger than a half, which is 0.5. It's bigger than 0.75. So, but it's smaller than 1. So we know it's going to be really close to 1, and it's positive, so it's really close to 1 right there. And then we have this -2/1. Well, what does that mean? Well, -2/1 is just -2, right? That 1 doesn't matter. So we would put that right there. That's -2/1. Okay, most of the time they give you letters that you would put on there. Okay, so really think about it. Is my fraction bigger than a half or less than a half? Or bigger than 1/2? Or smaller? Where is it going to go? That is the main part with fractions to starting to learn how to estimate where they should go. And then we'll work on doing it to the quarter, okay, to the half of a half, if you want to think of it that way. Okay, so don't let this equation freak you out. We've given you all the info you need. It says the speed of a car changes from 37 feet a second to 102 feet a second in 5 seconds. What is the acceleration in feet per second squared? So when you look at this, here's our main numbers here. Our equations given to you, acceleration, which is what we're looking for, equals the final speed minus the initial speed over the time. So this is the key, the final speed and initial speed. Final speed means what? That means what you ended with. Okay, initial speed is where you started, the speed you started at. Okay, or the beginning. So this says it changed from 37 to 102. Okay, I think I wrote that backwards. So we started, so the final speed was 102. Yeah, sorry, I wrote it backwards on my paper. The final speed is 102. The initial speed was 37. Okay. over t, which was time, which is 5 seconds, and this is acceleration. Okay, so 102 minus 37. Is that right? Yeah, I wrote it backwards. Okay, so 12, so 6. I'm sorry, 5. Oh my gosh, now I'm all flustered. La 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 la. Let me get my eraser. I don't know why it's written that way on my paper. Okay. So this should be a 5. You guys know how to subtract better than me. So 102 minus 37, so that's going to be 5, and then 9, 8, 7, 6. So 65 divided by 5. 5 goes into 6 once. 5 goes into 15 3 times. So acceleration is 13, and make sure and label feet per second squared. Feet per second squared, okay? So the big thing here is knowing this number, this 102, is not always going to be faster. It's not always going to be first. I mean, it depends on what you started with. You could be slowing down or you could be speeding up. It depends, okay? Though, since you're accelerating, I guess technically you're going to be getting faster on these problems. But just make sure and read those really well. And there we go. There's that problem. I think we might have one more. Okay. Evaluate for x equals 9, y equals 3. So again, we're plugging and chugging. Make sure you put in the parentheses. So -2 times 3 over 9 squared. So this x goes down here and the y goes there. So -2 times 3 is -6. 9 times 9, do not put 9 times 2. 9 times 9 is 81. Okay, you always, from here on, you have to reduce unless it tells you otherwise. So don't ask me. Yes, you have to reduce. Okay, so we know our answer is going to be negative. It doesn't matter where it is or where the negative is. So we know that 3 will go into both of these. So 6 divided by 3 is 2. Whoops. Okay, 81 divided by 3 is 27. Right? Yeah, 3, 2, 6, 7, 8. Yep. So, and this will not reduce anymore. -2 27s. And the negative can be in the bottom, top, or in the middle. You just have to have one of them. Okay?